Okay, on the back here, we're going to do numbers 5 and 6 only. We are not going to do number 7. And number 5 is asking for, given these terms in the sequence, fill in the missing numbers for the, notice it says here arithmetic sequence, and then there's separately the geometric sequence. Notice they're using the same starting and ending numbers, but one is adding or subtracting and one is multiplying or dividing. Okay, so using our little formulas as a basis, remember we could say begins with 972. Adding 1, 2, 3 jumps of some unknown common difference ends at 36. So it begins with what, adding what, ending with 36. We're going to subtract the 972 from both sides and then divide by 3. So I'm grabbing my calculator right now. 972 minus 36 is negative 936. Dividing by 3, divided by 3 is 312. My common difference is negative 312. And so that's what I'm subtracting by. So let's go fill in those blanks. 972 minus 312. That's going to give me 660. 660 minus 312. That's going to give me 348. 348 minus 312, that gives me 36. So I just checked that. Now I need to go one in the other direction. So I'm going to go 972 plus 312 to go the other direction, and I get 1284. All right, that's for the arithmetic. Remember how there was another way that some students were doing this? Some students like to do the slope formula way. Hang on. Where we go y2 minus y1, or 36 minus 972, over, and so these terms would be like 1, 2, 3, 4, 5, over the 5 minus 2, the fifth term minus the second term. We're doing the y minus y over x minus x. By doing it this way, you would still get negative 936 divided by 3, and you still get the same common difference of negative 312. So if you liked that slope way better, like the subtraction way, y minus y over x minus x, great. If you like this common difference way, or at least that you're comfortable with this common difference way, great. Let's go do the geometric, same thing, but this time multiplying. Begins with what? Multiplying by what? 1, 2, 3 times. Ending with what? We're going to divide out that 972 to get r cubed equals. Now there's a couple things to do here. First of all, 972 divided by 36 is 27. So if you happen to notice that 36 can go into 36, 36 can go into 972, it would make it easier if you reduced that fraction down to 1/27. If you didn't notice that and you made this a decimal, you can still do the cubed root of something. But if you can see that this is a 1/27th, it's going to make it easier to do the cubed root without a calculator. So taking the cubed root of r cubed, taking the cubed root of 1/27th, cubed root of 1 is just 1. Cubed root of 27 is 3. What's my multiplier here? This is a 1/3 multiplier. So 972 divided by 3 is 324. 324 divided by 3 is 108. 108 divided by 3, just double checked it, I got 36. And then going the other direction, 972 times 3 is 2916. How'd you do? All right. Going on to this next one, Joseph and Ricky are trying to see how we can get the most followers on Instasnap on the first day Joseph created the account. So on the first day, time one function, he had 100 followers. So we're talking Joseph right now. So we're going to go f of 1 equals 100 followers. And then they increased by 15 each day thereafter. Hang on, by the way, did they tell us what to call this? F of D, number of days. F of D is the number of followers. So hang on, F of D instead of F of X. F of D equals F of D minus 1. And then we're adding 15 each time. Okay? Number of followers increased by 15 each day. So this right here is what makes that. That's my recursive. That's for Joseph. Next, for the explicit for Joseph, we say f of d equals began with 100 followers, increasing by 15 every day after day 1. So d minus 1 from time 1. So this right here, the 1 comes from this, day 1. The 15, just like before, comes from right here. The 100 comes from right there. There's my explicit. How'd you do? Next is on the first day, Ricky. So let's go do a different color for Ricky. Let's do pink. On the first day, he had 5 followers. Okay, so Ricky, on his first day, he had 5 followers. I'm actually going to call this R of D for Ricky. Actually, I'll just stick to F of D. Sorry, guys. It doesn't give us another name, so let's just keep it simple. Okay. Then we say that for him, he doubles his number of followers each day thereafter. So that's a times 2 for our recursive. So writing this explicit, F of D equals, began with 5, multiplying by 2, each time to the power of D minus 1. Remember, you can have those parentheses or not, it's fine. How are you doing for recursives and explicits on this? Now it says to graph the number of followers for both boys. So I need to get up to 100. And this one's starting lower, but so let's just go over to the side here and see. So if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I went by hundreds, so 10, 20, 30, 40, 50, 100, 150, and 200. What's going to be represented on the side here is our number of followers. What's going to be represented on the bottom here? It's our number of days. This is our D axis. This is our F of D axis up here. And so down here, I'm just going to count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's go graph it. On day 1, for the linear, or for the Joseph one, there were 100 followers. From there, we go up 15 over 1, up 15 over 1. I'm counting by 10, 20, 30, 40, 50. I'm counting by tens. So it's going to be up like a square and a half. Up a square and a half. Up a square and a half. Up a square and a half. So every other one will actually land on a corner. So that's kind of nice. There's my linear function for Joseph. How's that looking? Now, if starting at 100 and going up 15 didn't make sense for you to grow that, you could always make a quick table over to the side for Joseph if you felt like you needed it. Okay? Okay, next I'm going to go begin at 5. Remember, each of these is 10. So on day 1, he had 5. I'm going to make this one gold. So on day 1, he had 5. I'm way down here at like the half mark. Now this is doubling. So what's 5 times 2? 10. On day 2, there were 10. On day 3, double of 10 would be 20. On day 4, double the 20 would be 40. Double the 40 would be 80. Double the 80 would be 160. I still haven't crossed over. Double the 160, I'm going to be way up here out of range. I can't even graph it on my graph, right? It's way up high. Okay. Now, is there such thing as a half day, like the middle of the day, or a half follower? Would I connect this graph? Sometimes it's easier to see. Don't connect it yet, but sometimes it is easier to visualize a graph when it's connected. Like it's easier for me to see what's going on with this graph when I draw that line. And it's easier for me to see what's going on with this graph when I draw that line. I can actually see that those two curve and line will intersect at some point. I don't know exactly what that point is, but should this be connected? I would say no, probably not, because a half follower doesn't really exist, right? You either have 1 or 2 or 3 or 100 followers. There's no such thing as a half follower in between. So I would keep this graph discrete or dots because of the context, because people can't be split in half. At least we don't want to. I don't know. Do you want to? That's kind of weird. Okay, how'd you do on this? That's the end of the video.